Hello and welcome to another tutorial. In this tutorial, I'm going to continue our discussion on executable binaries. We looked at the terminal. We said that it's a very important topic, and then I recommended that if you're using macOS and Linux, try to use the fish application, which is a shell that runs on top of your current terminal. It's a very nice interactive, and it has color highlighting and very nice features like auto completion and suggestions for which flags to use for known command line binaries, right? So the executable binary, let's have a quick look at this, because this topic is important for understanding what happens when we go into the GraalVM native image, right? So first of all, in any operating system handles your data through files, right? So files or directories. Remember, a directory is just a file that is has an attribute that tells the operating system to treat this differently, right? So files are the actual binaries that are stored on your permanent storage, right? Here, obviously, if something is in the RAM, which is a non-permanent storage, we don't call it file. We call it some data that is in the memory, right? So when we say file, it means some data that are on permanent storage. And the way operating systems handle files is that they kind of organize it in the way that the operating system understands. That's why the concept of the file system for the operating system comes into play. Windows, the old systems, FAT32, FAT, and then Windows switched to NTFS, which was the newer version. macOS used to use the extended file system, and now they switched to Apple file system or AFS. Linux also uses its own file system, right? So file system changes from operating system to operating system, and that's how basically the operating system organizes the files or your data on the permanent storage, right? So every operating system organizes this data and knows how to access and reads the data or store right to the hard disk in its own way, and it changes from one operating system to another. So if you are inside when you open up terminal, as I mentioned before, you're inside some working directory, right? Usually the default working directory is the home directory of the user, and I mentioned that previously that a computer can have or when you install operating system, you can define multiple users for that computer, right? And then operating system creates a home directory for every user. So when some user logs in with their credentials, they are directed to their own home directory, and then they most likely don't have access to other users' home directory unless some super user or the administrator logs in with the administrative privileges and then enables access of one user to the home directory of another user, right? But by default, one user doesn't have access to other users' home directory. And home, inside the home, usually you have the desktops directory, application, documents, downloads, etc., right? Movies, pictures. So and usually when you install an application as a user, that application usually takes advantage only sees the user's home directory. It doesn't see the entire computer, right? And if you open up terminal and you want to list all the everything that is inside that directory, you use ls in macOS and Linux. In Windows, you use dir, which means directory. ls is the shorthand for list. And then -l is a flag, and I mentioned before that whenever you have an executable binary in the terminal, you type it, it means it's the name of the application, and using the path environment variable, the terminal and the operating system can search for that binary. In this case, it's ls. And then -l is a command line argument that we pass to the ls application. And then -l means create a long list, right? So format the results in a long version. If you want to see hidden files, you can say, for example, -a, which means all, a small a, show hidden entries, right? Here in the fish shows you all the flags that are available for a command. And what you see inside is that if I run ls-l inside home directory, the blue is all the stuff that are here, and right now they are all directories. And you see the file permissions or file attributes, and the format is again, this is a format for unix-based operating system like macOS and Linux. And there are basically 10 characters that one extended character at the right side. In this case, you see some of them have plus, some of them have at, some of them don't have any. So for now, let's focus on this default 10 character. From left to right, the first character sets the attribute whether this is a directory or a file. And again, file and directories are more or less the same thing, and the main difference is that directories have the executable attribute. What this means is that if you recall, we said that when we talked about the terminal, we said that you can change the behavior of a file from non-executable to executable by using the chmod command, right? And then it just sets the attribute, this X attribute. And you can probably guess that each group of 3 characters, you can probably guess what R, or W, and X are, right? R is read attribute, W is the write attribute, and X is the executable attribute. And again, because on a computer we have multiple users, and some users together can form a group. Therefore, we have 3 types of categories for permissions. One is the user or the owner. If I create a file, if I log in with my user credentials on my operating system, let's say I go to my home directory or desktop or somewhere else and then create a file, I'm the owner of that file, and that file exists on my user account, right? It doesn't exist on some other user's desktop. It only exists on my desktop, and operating system organizes and manages this behavior. But then usually operating systems like Linux, macOS, they have from the root directory, they have a shared directory, which means every user can put a file there and everybody can have permissions to access, read those files, or maybe write them, okay? But by default, one user doesn't have access to the home directory of another user. Now, if I create a file, I'm the owner. So the first 3 characters, obviously the first character means it's not a directory. If I create a text file, it's not a directory. So instead of having D, I get a dash. Dash means that attribute is not set or doesn't exist, right? So basically when you have D, means the attribute that this file or this for example applications is a directory, and that attribute is set. If if it's a hyphen or a dash for the first character, means this is not a directory, it's a file, because the attribute for a directory is not set. And as I mentioned, files by default are executable, which means now you can this attribute directory or file, right? This first character determines what happens when you double click on something that operating system shows you, right? If it's a directory, means it is executable, which means if you double click, some application will get executed. In macOS, we know that if I double click, if I open a window or directory and then double click, what happens is that the Finder application opens up and shows me the inside that directory. So it means when I double click on that, an application gets executed. That's why directories always have this X permission, which means directories are executable, which executable means what happens in the graphical interface of your operating system, what happens if you double click on that file, right? Now if you removed, if there is a directory and then you remove this D permission, right, and then it's no longer going to be a directory. So let's head to, for example, Eclipse here. This is our previous example, and I am going to first of all, let's open up terminal here in this root directory of our project, right? So let's see what happens. This is our current working directory, and if I say ls, it just shows me that I have these kind of things, and this coloring applies to directories. And by default, my very nice fish shell, it tells me that a directory is distinguished with a file if there is a / here, which means this test tree is definitely a directory, not a file, right? If I say ls-a, it shows me also the hidden files. So current directory, the parent directory, .classpath, .project, .settings, which is a directory. As you can see, So this coloring very nice, distinguishes them. The other way to distinguish a directory with a file is that this fish shell adds a forward slash to the end of the names that are directories, whereas these two .classpath and .dsstore or .project, these don't end with forward slash, which means these are files, right? And obviously we know that every directory in every operating system has two hidden directories. One is the current directory and the other one is dot dot, which is the parent directory. And then you can use the cd or change directory command dot dot forward slash, and then you go to the parent directory, right? And then I can go back to the directory itself, right? But then the idea here is that for directories, if you're just changing the directory, you don't need, for example, to type the forward slash. I mean, it's recommended to always type the forward slash so that you explicitly distinguish between a file and a directory. But even if you don't type it, the terminal has no problem understanding that because of the file attributes or file permissions. So if I say cd, let's go up. So instead of using the forward slash, I'm not going to use it. It still works fine. It goes to the parent directory. Let's clear it up. Say ls-l, long list. Now you see what happens here is that as you can see, all these attributes, and let's also combine the -l with -l, -a, -l, or you can combine them -al. So it shows me the current directory, parent directory, some files, and then some directories, right? And again, this forward slash is there, so it shows me that. But besides that, it also tells me that directories have the directory attribute to set, whereas the files don't have this character set to its hyphen. Hyphen means this attribute is not set, all right? And you see every directory has an executable attribute set, whereas a file by default it doesn't have its executable attribute set. So a directory is executable in the sense that basically if I open up a Finder window, which is the way the operating system provides file management to the user, this is a directory. It means it's a file that is executable. So if I double click on it, something happens. Some application gets executed, and that application is the actual Finder itself. On Windows, it's a File Explorer, for example, right? Because then it gets executed and it loads the contents of that directory. That's why when you look at the file attributes of a directory, you see that it's directory, but it's always executable, which could sound a little bit odd. Why do directories have an executable attribute? That's because when you double click on them, some application gets executed, which is actually the Finder or whatever file explorer that the operating system provides, right? That's why directories are executable. Now, if I show my hidden files in macOS, right? So if I go to here and then let's see. So we go into the Java. This is our project. That's what we're looking at in Eclipse. There is a file here, right? If I double click on this, nothing that happens because this extension .project is not known to the operating system. That's why these don't have an executable attribute. And we said that you can actually write scripts, shell scripts, and they usually end with .sh. So let's say touch. Let's create a file in this Java native image directory called runme.sh. So touch means just create a file. So you see runme.sh is created, and then we're going to put some text here. So the way you can do it in terminal, you can, for example, run vim, or I'm just going to say concatenate with the cat command ls-la, and then I'm going to redirect this to runme.sh. Let's allow this. Let's look at the contents of this in the editor. Nothing went there. So I think what we need to do, let's see. Oh, so what we need to do, we actually need to, I guess, echo it. So echo this text ls-la, But then instead of redirecting to the terminal, we redirect the output of this echo command to a file, right? And then if I say less run me dot, this less is a command line application that shows the contents. It says ls-la and we hit Q, we go at. All right. Now if I do ls-la, it tells me that this run me right now, it's not a directory, right? And then what happens if we change its mod, change mod, chmod plus directory run me.sh. It says invalid file mod plus d, right? So you cannot really convert the attribute of the directory to non-directory. I mean, that's something that the operating system determines, right? But for the rest of attributes, the read, write, executable, you can change that. So that's the first thing we want to do, right? If I say from current directory run me.sh, it says the file run me.sh is not executable by this user, because if you look at the attributes, the first 3 characters after the first character, it's RW and executable. For the user, I'm the owner of this file because I just created it in my user account. So we're going to say chmod, change the mod of this file to +x, add the +x, and then run me.sh. And now if we clear and look at ls-la, it tells me that again, now the user has X attribute, and then everybody, even the group has X attribute, everybody else has X attribute. So when you say chmod +x, everybody gets attributes in terms of executing. And the fish shell also changes the color to red and puts an asterisk here, which means this is executable. Basically, it means this is an executable file, and you have the basically rights or the permissions to execute it. This asterisk means you have the permission to execute it. So if I say run me.sh, it basically runs the command that is inside here, ls-la, right? And that's how this works. So you can create shell commands. For example, here I can also, after this, I'm going to create another one, cd, and then saying that ls-la, and then cd, go to basically the name again. So Java native image. So we wanna, this shell command script has 4 commands. So let's see what happens. Now we change its content, but it's still executable, so we can just run it. So if you modify it, the attribute of the executable is still set. So you can just say run me. And as you can see, this is the output of the first command, ls-la. And then we are going to the 1 level up and then running the second command, the third command, ls-la. But then we change the directory back again to the whatever we started, right? So you can chain these commands, and then every line gets executed, the output, the terminal shows your output, and then you can so in macOS and Linux, you can use the .sh scripts to write terminal scripts, and then in order to make them executable, you can basically use the chmod and change their set their executable permission. For example, you can just type java -- version, and I'm going to just run this again, and it tells me Java 7. So it exactly runs this command, right? Java, and you will see that later on when we get actually to the compiling our Java application using native image, we will write shell commands, shell scripts to automate the process and makes it much easier. And when you write the shell script, you can make it executable.